This is a video on alternating series. The question states, determine if the following series converges absolutely, conditionally, or diverges. We have the sum from n equals 4 to infinity of negative 1 to the n over n minus 3. So first note that we do have an alternating series because of this negative 1 to the nth power. So when we have an alternating series, we have to decide if it converges or diverges, and if it converges, is that convergence absolute or conditional? We do that by looking at the absolute value terms. In other words, we take away the negative 1 to the first power. We could say that the absolute value of a sub n is just 1 over n minus 3. And looking at this, we can see that the limit as n approaches infinity is clearly 0. So it doesn't look like this is going to diverge. Also note that this looks a little like the harmonic series, 1 over n, which diverges. So our guess is that it is conditionally convergent. So now let's show that. We're going to start with the alternating series test. We need to show the two conditions. The first condition is that the limit as n approaches infinity of 1 over n minus 3 is equal to 0. But that's certainly true if n goes to infinity. Infinity minus 3 is still infinity, and 1 over infinity goes to 0. So that's true. We also need to show that 1 over n minus 3 is a decreasing function of n. So to show something's decreasing, I take a derivative. I'm going to use the variable x because I'm used to it. And I take the derivative of 1 over x minus 3, and I get negative 1 over x minus 3 quantity squared. Notice the numerator is negative, the denominator is a square, so it's positive. So this fraction is negative. So we know that when we have a negative derivative, the original function is decreasing. So we now have the two conditions. The limit is 0, and it's decreasing. So we can say by the alternating series test, the series summation n equals 4 to infinity of negative 1 to the n over n minus 3 converges. Now we have to decide absolutely or conditionally. And again, we're looking at 1 over n minus 3. So our guess is that this conditionally converges, and we're going to compare it with the harmonic series 1 over n using the direct comparison test. Notice the inequality. 1 over n is positive, and also 1 over n is always less than 1 over n minus 3. And that's because if we have a larger denominator, then we have a smaller fraction, and n is bigger than n minus 3. So we can say that 1 over n diverges. We know that's true by the p-series test or the harmonic series. P equals 1 here. So if we know that the sum of 1 over n diverges, and we also know that 1 over n is less than 1 over n minus 3, then the direct comparison test tells us the series summation n equals 4 to infinity of 1 over n minus 3 diverges. So if we have a series that converges, but when you take the absolute value of the terms, the corresponding series diverges, we say that the series summation n equals 4 to infinity of negative 1 to the n over n minus 3 converges conditionally. And I'm done with the problem.